the operating system, whether it's user, whether it's application, etc., whether it's paging, we go very, very granular. And number two, once we know what that I/O is, we build a specific type of cache for that I/O. So unlike a generic caching system that kind of treats all I/Os the same, we build very, very specific caches for every type of I/O and keep them within this appliance. And the next application when you can characterize I/O or figure out what it is you can deduplicate it inline as it's flying over the wire. So as the I/O flies over the wire, we're able to take duplicates out. So what that means is that if user A and user B install, for example, the Chrome web browser in their environment, there's only one physical copy of Chrome that will actually get installed in your stored system because we will inline capture all the duplicate bits of that particular install and just dereference it and put a pointer in its place. So we're able to do this in flight, real time, and to my knowledge, that's probably a very unique application of the technology. So these two capabilities allow us to do the most important thing, which is offload your backend storage by 90 to 95%. So what that means is 90 to 95% of I/O that used to go and get serviced by our storage now gets serviced by our clients. So as a result, you no longer need all those spindles to service the I/O. So that that basically means that you spend a lot less money on the storage system and build a much more high performance environment as a result. So I guess I'm out of time, so I just wanted to kind of give the drop the 30,000-foot view. I don't know how much time I take you on the time constraint, but if there are any questions, I'm happy to answer those.
One thing is getting to the question that you're talking about here. Is it really a playing and saving the IOPS, or is it distinct?
It's a great question. It's actually a combination of both. One, it's about saving storage by generating the IOPS in software rather than in spindle. So you no longer need to buy hard disks and fiber channel drives to generate the IOPS. Our appliance generates it in pure software for you. The second thing that it does is it duplicates all the I/O. So as a result, all duplicate information, and in a virtual environment, believe me, 95% of the information is duplicate. The same operating system and the same app, the same stuff that end users are doing. All of that is eliminated from being needed persisted to the storage environment. You need a lot less physical storage capacity. So it's really a combination of both. And so what we can do is we can cut the storage by 2 times. And that's the scientific, technical number, the marketing number. Yes, the marketing guys will probably tell you 100 times, but it really is 20 times. It means that if you're using a 20 terabyte SAN environment today, which is really expensive, 6-digit number, we can cut that down 1 terabyte of physical storage capacity and still allow you to deliver IOPS than you could from a SAN environment. Each of our appliances can deliver 1,000 IOPS in the front end to pure software. And the idea, a fiber channel drive, one of the most expensive fiber channel drive, fast drives is 15K RPM drive. You can get about 180 IOPS. So you need a lot of those to be able to generate 1,000 IOPS, which is what one of our OneDuo appliances can generate to serve the VDI environment. Yep. Any other questions?
What's doing the processing? I can see how you're saving a lot of space, but something's got to do a whole lot of math to make that magic happen. And how are you storing the index of all that stuff so that you're not using more of those IOPS for that?
I'm sorry, I missed a part of that question. If you don't mind repeating the
let's just start with the memory in processing. What's doing the processing and the management of your memory of of whatever the process is that's actually running? Is it running on the client? Is it running on a server in the middle? Where's it running?
Everything runs on our hardware appliance in the middle. There's nothing that's inserted into either the hypervisor or the storage or into the gun. It's a completely transparent solution. And what our appliance is just a regular x86 server, from Dell or one of those guys. We've got an OEM with them. But, it's really the software that's running on it, which is the secret sauce. What it does is it builds different kinds of fine-grained caches on the appliance's memory for different types of I/O.
Questions?
So far, he's talked about everything coming from the machines out there to the storage. Is there any modulation necessary through this appliance when the data goes back out to the machines?
If I could summarize, what's the process in reverse?
Yeah.
So what you're talking, what's the process in reverse? You talked about going from the host to the client. What's the reverse process?
Well, the reverse process of reading really means that any I/O that is required by the server or the guest operating system, 90 to 95% of that I/O is really served from our caches. That is served from the appliance itself. I'll just put one more slide that'll give you an architectural idea of how this is deployed. My PowerPoint is stuck, but yeah.
So we've noticed.
Okay, I'll just do one quick one about how this technology gets deployed. The product is called Helio, and it's a very, very simple deployment. I'm struggling with the slide over here. Well, basically, you've got a back-end storage. So what I have over here is the back-end storage system. It could be a SAN, it could be a NAT, it could be direct NAT storage. It doesn't really matter. And you've got some form of network coming out of that core storage network. It could be gigabit Ethernet, 10 gig Ethernet, it could be fiber channel. All of that comes to terminate at the rack level, at the top of rack switch. And inside each of these racks is a bunch of servers that's running on hypervisor that's close to your desktop. So that could be Zen server, that could be ESX, that could be Hyper-V. At the top of each of those racks, we deploy one of our appliances. It's a one new appliance, and basically the storage comes into the top of rack switch and terminates in our appliance. So it either comes as fiber channel, or it comes as iSCSI, or it comes as NFS, and terminates within our appliance. And from our appliance, then gets distributed to all the hypervisors that are running within that rack. So if you have a hypervisor in that rack, it's a Zen server. The Zen server really sees a data store coming from Helio as its primary data store, and finds all the PHDs and volumes on that particular data store. Same thing with ESX. The MDKs that it sees are coming from the Helio appliance that is processing the storage system at the back.
Two-part question. How are you doing indexing? Where's the index stored? And what do you do in the case of like a failure or a move of a database? Something that's going to impact a lot of those links.
Well, yeah, I got to talk a lot more about architecture to answer that question, but very simply put, the appliances themselves are entirely stateless. So effectively, whatever they do it within the context of a particular session and a particular desktop. For a failover, we basically rack two appliances together and put them in a failover mode where they replicate against each other. So they do a full state replication against each other, and it can do a hotspot where if the primary appliance fails, the secondary appliance takes its place transparently without interruption of connection to the desktops.
Okay, I guess we have a request from the room then to see if you could maybe schedule a return trip, maybe around Deep Dive Day.
Yeah, absolutely. They want me to come back and do a deep dive, so.
Yeah, so maybe you can talk to Tim while you guys are together about that process and, what has to happen on your side, what we got to do, etc.
Thank you. Yeah, absolutely. I look forward to doing that. I'll hand the phone back to Tim now.
Okay, thanks.
Thank you.
Thank you all for coming. We are just about out of time. Let me just wrap up with a couple of comments. One thing that I promised that I would tell you that I didn't, so I want to get it out there while I'm thinking about it, and that is, so how do I use my wireless network to access access my guest machines? So simple networking. Whenever you create an internal network, it creates a network adapter on your host, right, on the parent VM. All you got to do is take that and an external NIC, right-click, do a multi-select, right-click, bridge, simple networking. It's going to automatically bridge. Anything that goes to one network is going to pass it to the other, and vice versa. So I basically created an internal network on my Hyper-V system. I called it Internet, and I've linked it actually to my wireless card. And my wireless is what I use for Internet. So that's how I did that. Now, that throws away a lot of some of the stuff that we talked about in security, but from a performance standpoint and a demo machine and usability, it's very, very easy. It uses simple networking technologies.